Closed.
Nice.
Okay. Mariana, what do you see, or what does everybody see?
We see your slides.
You see my slides in presentation mode or in regular mode?
In the presentation mode.
Oh, excellent. Okay, well, first off, thank you so much for attending, and thanks a lot for inviting me to this. This is such an honor to be at the Ukrainian workshop, given all the circumstances that are happening. And when I got the invitation from Mariana, I was, flabbergasted by the invitation to start with, especially given the context and the historical context that we have right now. So unfortunately, I don't work on Ukrainian specifically, but I'd like to address something maybe would be of interest to Ukrainian research, but also to low resource languages in general. So as Mariana mentioned, I'm talking about the criticality of low resource language research for a sustainable NLP future. So before moving into the meat of the presentation or the talk, I'd like to set the ground around what NLP and CL are. They're really concerned with the interactions between computers and human language, in particular how to program computers to process and analyze large amounts of natural language data. And the goal of computers is a computer capable of understanding the contents of documents, including contextual nuances of the language within them. So basically, CL develops computational methods to answer scientific questions of linguistics, where humans are computing, what humans are computing and how, involving the nature of linguistic representations and linguistic knowledge. NLP is really the art of solving engineering problems that need to be analyzed natural language text. So in general, oops, why is this not working? Okay, let me double check. Yeah. Our field is concerned with scientific generalizations, but also technological utility. So NLP, what is the future? With the mainstreaming of NLP, the advent of generative AI powered by large language models, we're at an inflection point in our field. Could we turn this into the diamond era for NLP? And how can we ensure the longevity and sustainability of NLP? So in this talk, I'm going to talk about my vision for using low resource language research as a pathway to a sustainable NLP future. Sustainability of NLP is critical, I believe. So is NLP saturated? I believe not. We need to grow in terms of solution systems, users, researchers, and developers. And I believe that D&I, diversity and inclusion, are a cornerstone of NLP growth. And in order to ensure the longevity of the field, we need to heed the impact on the environment, say green AI, also collaborate with other disciplines within CS, linguistics, and across the campus, making sure that our discipline is stronger and more resilient. But also help shape policies and regulations that allow our voices to be heard and leads us to shaping the future of NLP investments. Today, the talk is going to focus on the first one, especially around the questions of saturation and around D&I for NLP growth. So what are aspects of sustainable NLP? Accessibility, reaching more people in various communities in all languages, lowering the entry user barrier costs in the field. It has to be useful, relevant technology, improving people's lives, but also needs to be maintainable, continuously growing communities of researchers and developers, transparent, the dissemination of knowledge through accountability, and needs to be benevolent for societies avoiding harmful impact, and also for the environment. One avenue for diversity and inclusion is around research and development of NLP for all languages and all peoples of the world in their local languages and vernaculars, ensuring utmost utility. So why D&I should be a cornerstone of sustainable NLP? Morally, given the utility of our technology, it's incumbent upon us to ensure accessibility and adoption by all people, giving them the freedom to reject it if they choose to. Otherwise, it's a form of disenfranchisement. But also scientifically, D&I serves as a forcing function to think of low resource scenarios, where a low resource requires not just a language presence digitally or speakers, but also culture, domain, topic, resource availability. And if we adopt this perspective, then even the English language has low resource scenarios. And opportunistically and strategically growing our communities by using our technology to make the science accessible, take NLP sciences to local communities, leading to more inclusion and diversification. So how D&I, what's the bird's eye view here? More users need to have better access by lowering the accessibility bar, more efficient systems that could fit on smaller and cheaper devices, for example. Believe it or not, majority of the world population is not on the internet. The web is not a reflection of the world cultures and languages as of yet. And also ensure our teams are as diverse as possible to reflect different viewpoints. And it's not, I don't believe this is also sufficient, even though we try to aim for that, as it's capped by team capacity, hence the need for attracting homegrown talent to work in NLP in local markets to achieve mirroring effects, increasing the global NLP balance. And increasing our NLPers pool by demystification of our sciences, especially at high school level, generating scientific materials in different languages, side effects of unlocking NLP creativity in a truly global manner, evangelizing NLP through global media, encouraging conferences and outreach programs in diverse locations. We're taking NLP to more parts of the world. Think about the global south. What if NLP is not diverse and inclusive? Basically, we'll be amplifying by indirectly and even directly amplifying the global digital divide. And I strongly believe that language is politics. It's a vehicle for cultural and communication. Depriving the field of rich diversity in cognitive skills, creativity, curtailing the field's potentiality. But importantly, NLP would have failed at its mission of catering to all peoples of the world. I think of an analogy here, think about medicine, the medical sciences. If they only cater to and study and keep track of white, Western European, American males, ignoring other races and genders, how would we judge that? And believe it or not, a lot of studies have shown that a lot of medical studies have been, focusing on one segment of the society, which renders a lot of their observations very specific, unfortunately. So what is the North Star? I have a dream. We have NLP practitioners and researchers carrying out NLP research in their local languages. And how do we start from the top of the funnel? How? We start from the top of the funnel. Every STEM program worldwide has an NLP component. Believe that if that happens, that would be amazing. And to boot, it could be in their local language. So this is a map of the world. And we all sort of know this, but there are really 7,000 languages spoken in the world, globally, worldwide, 3,000 of which are written languages. So almost less than half of that number is actually in a written form. So you only think about it, majority of languages of the world have no NLP tools or even digital presence. And the majority of the world languages are low resource languages from that perspective. And as I mentioned earlier, all languages have LRL scenarios. So even English has that. Think about domain genre considerations, presence of variable ethnolects, dialects, sociolects. Code switching. So a very interesting example comes from Moroccan Arabic that could have at least 4 to 5 languages mixed into a single utterance. English, Spanish, Amazigh, vernacular Moroccan Arabic, and even modern standard Arabic. But it also has variable scripts and orthographies, like Arabizi for Arabic, which is Arabic written in Latin script. Low resource languages typically is defined as those languages with low digital presence due to the low number of speakers, lack of digital content presence, endangered languages and dead ancient languages, for example, think of hieroglyphics, Demotic, ancient Greek, and so on. Languages with no writing systems or standard orthographies, and you have variable modalities, think about sign languages and so on. So I would like to focus initially on this lack of digital content presence. So what is the question that we're asking here? How much is sufficient digital presence to warrant a language not being considered an LRL, a low resource language? Okay, sorry, it's past midnight here, so I'm kind of like mumbling through this a little bit, so please excuse me. So in an attempt to increase LRL scientific digital content, we proposed the ACL 6060 initiative. This was announced last year at ACL. And it was part of an initiative by the DNI chairs for that. It was myself and Martha Yefu from Ethiopia. So for ACL's 60th anniversary, we enabled multilingual scientific communication, 60 languages across all modalities, text, speech, and sign language, basically increasing the accessibility during and post conferences. And the core theme is globalization via localization. And the idea is that the duration of this challenge initially was meant to be for a year from ACL 2022 to ACL 2023, but it looks like it's going to spill into 2024, which is great. And by whom? It's by the community for the community. Why 60-60? The idea is we wanted to unlock people's potentiality. So think about, dreaming. We never dream in our second and third languages being English. I hope that most people who are attending this, if they're from Ukraine, they're also thinking first in Ukrainian. I think in Arabic as well, being a native speaker of Arabic. Actually, I think in Egyptian Arabic that comes from a certain particular part of Egypt. So basically the objective is to democratize CL, NLP science, but also remove the ingrained language bias in the scientific landscape and provide all a voice to unlock their creativity and innovation without a language barrier. So empowering scientists to think scientific in their native tongues, inspiring younger upcoming STEM scientists, but also creating scientific language and terminology in many more languages. And current advancements in CL technologies are mature enough to take this on at scale. And the question that keeps arising time and time again is, are we giving up on English as a language of universal science? No, we're not. But how 60/60? So the way it was devised, the SEED 60/60 initiative started in effect in March 2022. We had 6 work streams: speech translation, looking at cross-lingual subtitling and voiceover, X-dubbing, text translation for the ACL anthology titles and abstracts, including ACL 2022, scientific terminology curation and wikifycation, sign language interpretation, and slides and presentation translation, as well as website creation. So this is a global collaboration across academia, big tech, medium tech, nonprofits, and startups. And the aspirations by the end of the challenge is a comprehensive translation of the entire ACL anthology into those 60 languages, a complete, comprehensive, standardized scientific and CL terminology list with contextual examples in 60 languages, capability to have live cross-lingual CC, closed captioning and dubbing in 60 languages, a comprehensive repository for all talks and videos from the CL community, curated and translated, both subtitled and dubbed in 60 languages. And basically, we hope we would have spurred research into sign language. And we actually supported and sponsored the SPLAT ACL 2022 workshop, which focuses on sign language research. And start thinking beyond translation for democratization. So think about demystification of CL AI. So what was the call to action, and still ongoing call to action? We'd like to leverage our internal scientific community for crowdsourcing translations for all modalities. So please volunteer. And we have so many tasks that need all hands as well as leaders. So please step up and volunteer. Shared task, already we have interspeech, we sponsored interspeech this year in terms of funding. Actually, ACL paid for it under the, the umbrella of the 60/60 initiative. So other ideas are very welcome. So as a point of gratitude, these are companies that sponsored the initial seed: AI Explain, Baidu, AppTech, VI Global, Allen AI, as well as Meta. And there are it took a village to get the seed initiative going. We had if you check the website, it has a lot of very interesting things. So the ACL 2022 Organizing Committee, the ACL Exec, university collaborators, and of course, some notable mentions of some people who actually, dug in and put their hands together and created the first initiative. So let's move back to the topic of this presentation. So what is necessary for LRL research to take place? One thing that everybody agrees on is evaluation data, and in some cases, even training data, but evaluation data is critical. So it entails access to native speakers of the LRL, low resource languages, as well as localized guidelines and annotation tools, as well as designing LRL relevant tasks. So currently, the biggest challenges to LRL research are access to LRL native speakers and thereby localizing guidelines. But also the current predominant solution uses machine translation or human translation in less cases of original English tasks. So this is, it's a problem for several reasons. Basically, it's essentially the limitations are in the lack of good quality machine translation coverage of majority of low resource languages. So as of April 2023, Google Translate supported 133 languages. And remember, we had 7,000 before, or even 3,000. Let's just be, optimistic, 3,000 if we're just going to go for one modality. And Microsoft, for example, Translator supports 124. At Meta, we support 204 languages. But at any rate, the bottom line is it's a minuscule proportion of the languages that exist in the world. And when you think about translation, if you think about human translation, it's prohibitively expensive, especially at scale. And inherently, translation introduces biases from the source to target language, as well as, it could permeate not just biases, but also some level of cultural appropriation and so on. There are so many dimensions to this as a framework. But it is, of course, something that we leverage all the time. Then you have plausibility challenges in the target. So the target language could end up getting something that looks weird, but it's something that you would never say naturally in your native language. So I'd like to go into several use cases here to highlight some of these aspects. So this is annotation for training and evaluation for a low resource language. This was a paper that we published last year at ACL towards responsible natural language annotation for the varieties of Arabic. So the challenge, social content data annotation. So hate speech, similar to all social media content data, is quite challenging. You typically have low inter-annotator agreement as it relies on linguistic proficiency as well as cultural nuance. The problem was exacerbated for polyglossic languages, especially in social media contexts. So polyglossia means you have a context where several varieties exist side by side in the same culture, in the same context. So typically a formal and an informal variety. So in Arabic specifically, we have Arabic varieties. It's very well known as a problem in Arabic languages. And you see the same thing mirrored in Indo-Malay, Swiss German, and so on. So most NLP technology to date still targets modern standard Arabic, which is the formal variety. And it's quite distant from the spoken social media vernacular varieties. And the fact is, people express themselves in social media the way they speak naturally, which means they actually typically speak in the vernacular, in the dialect. Facts about Arabic. There are 420 million speakers of Arabic globally, 150 million Arabic speakers on Facebook app, 23 countries where Arabic is the dominant language. There are a broad variety of groupings. So you have Iraqi Arabic, Levantine Arabic, that includes Syria, Jordan, Lebanon, Palestine, Maghrebi Arabic, including Morocco, Tunisia, Algeria, Libya, Western Sahara, Mauritania, and Peninsular Gulfi, which includes Oman, Qatar, Saudi Arabia, Bahrain, UAE, Kuwait, Yemeni, which includes Yemen, Egyptian, which includes Nile, which includes Egypt and Sudan. Some of the relevant characteristics of Arabic varieties is the notion of a faux ami, or false cognates. So this is an example here, Sriticality, which means go to hell in in Moroccan Arabic, but may you have help in Egyptian or in Levantine Arabic. The varieties are mutually incomprehensible in some cases. So from Morocco to Saudi Arabia or Morocco to Yemen, it's almost incomprehensible. We can tell that we're speaking Arabic, but it's just very difficult to decipher. But the critical aspect of this is there are no standardized orthographies. So what was the problem that we faced at Facebook, at Meta, was that we had subpar Arabic hate speech detection. We did a root cause analysis which led us to identify problems in the human annotation processes. Most annotators of Arabic social media content come from one country, Morocco, and we basically wanted to prove that there is a need for more diverse workforce, reflecting the diverse content that we've seen. And the overarching objective was building a case for the necessity of low resource language native speakers in the team, addressing low resource language labeling. It is a tongue twister, actually, the LRL thing. So what did we do? We actually we ran an experiment where we did stratified sampling. We took text-based samples in Arabic script from Facebook platform that corresponded to 10 countries that were identified by IP geographical location approximation. So Algeria, Egypt, Iraq, Lebanon, Libya, Morocco, Saudi Arabia, and Sudan, and Syria, and Yemen. We had 3,000 samples per country. We had them annotated with a binary label of hate speech versus benign, according to some guidelines. We had 2 sets of labels per sample sourced from unverified annotators in Morocco, which are called AIM. So basically, they're most probably Moroccan, versus verified annotators with native fluency and country expertise per country. So we had 10 sets of these verified annotators. The evaluation metric that we used was leniency as measured by signal detection theory. So signal detection theory is a decision-making process that's represented as a mixture of Gaussians, one for benign content, another for violating content, and determines the implied threshold of the annotators in aggregate. So here are the results. The narrower the bar, the more consistent the annotations, meaning higher inter-annotator agreement between country experts and AIM annotators, those who came from Morocco, from a single country. Majority of the content in a country variety is not formal Arabic. This actually belongs to the vernacular. Except for Saudi and Algerian data sets, they had a higher percentage of modern standard Arabic, the formal variety. So just to highlight the results. So Saudi had the most inconsistencies, and oh, by the way, there's larger bars indicate higher inconsistency. So the bigger the bars, the bigger the inconsistencies in the annotations. Saudi has the most inconsistencies due to the variety of content, majority of the content in multiple Arabic dialects or varieties, and this is basically a reflection of the expat pervasive presence in Saudi Arabia. But what we found that was kind of interesting, the higher SDT indicates higher leniency. And in this case, for Moroccan Arabic and by Moroccan annotators, we found that annotators in Morocco were more lenient via SDT towards Moroccan content. So what are the observations? Leniency, as expressed through high SDT, signal detection theory, and consistency, narrow bar, together point to two potential interpretations. When annotators understand the linguistic and contextual content of the samples, they are more likely to understand the nuances of the content that make it benign, and may feel more comfortable giving a certain benefit of the doubt, leniency, to the content creator. So they would judge it to be less harmful. So what's the impact? Effectively, we refrained from treating Arabic as a monolithic language across the company, but also applying sub-marketization by major Arabic variety for labeling hate speech. And as a result, we had a playbook for social value content annotation, dataset creation for polyglossic languages, and think about this in a global sense for low resource languages. Some of the goals for this playbook are to ensure sufficient expertise to, at a minimum, understand the variety and context of the annotation, route samples to experts who are best equipped to field and process them, provide expert support and inclusion in the process for NLP design implementation, allowing them to be a voice for their local communities, where they're appreciated for their skill and ability to provide deep problem understanding. Also provide best practices, towards ensuring the annotation ecosystem for dataset creation is responsive to the relevant groups in the Arabic-speaking world, and by extension to local communities. And finally, limit representation of potential downstream allocative harms. Use case number 2 in this realm of data creation and evaluation data. I would like to just describe to you a Flores 200, which comprises 204 languages. It builds on the previous Flores 101, and it's basically comprises sets of 3,000 sentences sampled from Wikimedia projects, many-to-many benchmark parallel data set for those 204 languages. It's a high quality ensured by strict control processes. So it's only for evaluation, and especially for bilingual evaluation. So think about it, or multilingual evaluation. So it's really for machine translation. You can think about machine translation as sort of like the primary customer for this. So Flores 101 comprised, as I said, 101 languages, which is extended in the Flores 200 to 204 languages. So at a glance, it's 3,000 sentences from Wikimedia that were translated into these 101 languages. Each sentence on average has around 22 words. Typically, you would have a document that comprises around 3 to 5 sentences, and it corresponds to 101 languages. And they come from different domains. So, think about, Wiki Junior, Voyage, and travel, and so on. So the overall process for Flores 200 quality control was quite interesting, the way they carried this out. So you have a document that goes through a translation. We had 2 different language service providers, and we had workload divided by languages. And there was an automatic check, basically the length ratio, source copy, language identification, copy from public translation, and check whether there's a copy from public translation engine. because we wanted this to be, catered to by actual speakers of the language, native speakers of the language, as opposed to using something like Google Translate or Microsoft Translate or something. So we did a check to see the level of overlap between the translations that are rendered by the vendors through the translators, or versus what we can get from online vendors, online translation services. And then we did a human inspection, which basically looked at the grammar, the punctuation, the spelling, the capitalization, addition or omission of information, mistranslation, unnatural translation, untranslated text, as well as the register, like the linguistic register for the text. And if something passes the 90% score, then it's completed. Otherwise, it goes through post-editing. So a very strict, quality control threshold. And so this is a very nice data set that was actually catering specifically to low resource languages. Excuse me. And it was extended to 204 languages, as I mentioned. So basically, as a result of these two studies, LRL research, we should be encouraging native relevant tasks, but also recruiting the native LRL annotated talent and encourage LRL evaluation data sets. In general, approaches to LRL research have been, so I've spoken about data and evaluation data especially. Now I'd like to talk a little bit about approaches to LRL research. So in general, you can put them in 4 categories or 4 bins. General LLMs, think about ChatGPT, GPT-4 as a generalized, almost free LLM. Free for the end user, of course, not free for the developer or free for it's free in a very narrow definition, but it's too generalized and uncontrollable. We have monolingual solutions, which basically are specialized technology that we build for language specific problem spaces. So, I mean, one thing I can think about is language ID, like what we have for AIDA, which is a language ID for Arabic that does token level identification of text. And it's essentially the advantages of that is that it's language specific, it's very cognizant of cultural and linguistic nuances and so on. But typically it's expensive and not necessarily reproducible. Then we have the more generic or more generalized type of solutions, and they're in this big bucket of cross-lingual transfer. So think about XLMR. So it's generalized and cheaper, and it has a bootstrapping potential, but it's also a potential for propagating bias, and it's not culturally or linguistically tuned to your low resource scenario. And then you have multilingual solutions. Think about XGLM and No Language Left Behind, which are generalized, centralized, robust bootstrapping potential, but they're also similar to the cross-lingual transfer situation. They could be propagating certain types of bias. So there is a current study that literally was just published 2 days ago internally. This is not even published outside, but since I'm at the Ukrainian workshop, I'm going to share with you guys. Of course, with permission from the authors. It's a current study by meta researchers where they compared LLMs at different scales, specifically looking at Llama and ChatGPT, a multilingual information seeking QA for 18 languages. And these are some of the results they found. So Llama with a number of parameters on the x-axis and a closed book TDQA F1 on the y-axis. And you can see the disparity between the different languages. So these were not tuned on any specifically, non-English data. These were just basically using prompt engineering in the different languages. So you have English as the top bar, as the top curve over there. And you see the other languages following. Basically, across the 18 languages, they're all tend to be very low, all the way down to Korean. And it seems like, I don't want to say it's the observation is that the performance is slightly going up with scale, but even dipping a little bit with Korean down there. And these were, as I mentioned, language models that are not specifically tuned for, these are just generic language models. But this is not surprising given that training data for generic LLMs is based on web data, so Common Crawl. And in general, English is of course predominant. And just to give you a sense, so English corresponds to maybe 55.5% of the data that's out there. Arabic is something like, 2 to 5%. But then you go to Ukrainian, for example, is 0.6%. And this is as of May 1st, 2023. So that tells you like all these language models that are trained on huge amounts of data. Of course, there's other things going on with transfer of knowledge and so on across languages, but still, the web is not a reflection of the diversity that we have. So some of the observations they made that even the best language models still make a lot of errors. Knowledge transfers poorly across languages. Being correct on a specific question in English does not necessarily imply the LLM will be able to answer correctly on the other languages. And overall, the performance in non-English languages is so much lower, between 15 and 22 absolute F1 points. And this is a very rigorous study. So be on the lookout for a paper coming out from Muller et al. Very soon. The next one that I'd like to focus on is multilingual models. I'm going to skip monolingual ones. I think this audience know how to do monolingual ones and cross-lingual transfer. The multilingual ones are very interesting because I feel like they have a lot of potential together with the cross-lingual ones as a way of bootstrapping monolingual, LRL research in general. So I'd like to talk about XGLM, which is a multilingual language model that we built for multilinguality. And this was published in UNLP 2022. It's basically looking at few-shot learning with multilingual generative language models. It's called XGLM. What are the advantages of massively multilingual models? Basically, they're transfer learning, so low-resource languages learn from related languages. They reduce the complexity since you only have a single model that needs to be deployed in production, but also state-of-the-art quality. Bigger multilingual models typically outperform bilingual counterparts, especially in machine translation settings. And this was noted in WMT 2021. So the MT caveat, the primary source of data for training MT models is aligned bitexts. However, publicly available bytext is often scarce. So you end up getting this very interesting skew. So toward the right-hand side of this graph, high quality translation only happens for high resource languages. Low resource languages, by definition, end up getting low quality translations. So 148 out of 202 languages are considered low resource, unfortunately. So what is XGLM? It basically comprises 4 language models at various scales, up to 7.5 billion parameters, similar to GPT-3 on but it's trained on multilingual data. And how did we go about doing that? We had 30 languages from 16 language families, and we upsampled data from the tail of the distribution. We created joint subword vocabulary for all languages. And the performance, XGLM performs comparable to Anglo-centric models in 0 to few-shot settings. But I'd like to show you some observations. So XGLM in unsupervised and machine translation, we asked the question, does unsupervised pre-training on a diverse set of languages result in competitive translation performance? And these results that I'm showing here are results on the Flores 101 dev set using the Blue metric or variant of the Blue metric. Essentially what we found is that XGLM outperforms GPT-3 with a few exceptions on high resource languages and larger model versions, which makes sense that GPT-3, because it has a lot more data, it's of an equal number of parameters, by the way, or almost equal, but it's basically trained on a lot more data for high resource languages compared to low resource languages. So in a sense, it doesn't, it's not very surprising. But also what was surprising was that the XGLM models outperformed at least 45 out of the 182 Flores 101 language pairs. So it outperformed, supervised machine translation, meaning machine translation that was actually given parallel data for these languages. So that was kind of an interesting observation as well. Okay. How did XGLM perform on monolingual tasks? And that's another interesting observation. So we had monolingual tasks. Basically what we ended up doing, just in a nutshell, we took some of the evaluation data sets that were for, say, story close, COPA, and we had them translated into English, into these languages. And we also had, the prompting happening in the target language, in the low resource language, or the high resource language, or the medium resource language, and we compared that with translating. So the third row here in each of these tables corresponds to taking the prompt, translating it into English, and then using GPT-3, replicated by us internally and checking the results there. So the overarching observation is that XGLM outperforms GPT-3 baselines on almost all languages, given by the bold numbers that you see on the table, especially for low to medium resource languages, which is a nice surprise. Or maybe not a surprise per se, but actually it's a nice observation, because it actually says that, when you curate the data in smart ways and try to balance them out, then you end up you're reaping the benefits of that, especially for low resource and medium resource. Remember, we had to we upsampled a lot of this data to make it representative of, having better representation. But what's interesting about this is that we also observed XGLM's performance on English tasks. So what we note there is that it actually was trailing a GPT-3 and GPT-3 that we replicated internally. So this is an interesting observation because, and these are challenging tasks. So we're talking about Story Close, COPA, Winner Grande, LSWAG, ArcEasy, ArcChallenge, Pika, and Open Book QA. And we had one, big overarching question: why is downstream performance in English tasks affected by the shift of language distribution in the pre-training data? So we acknowledge that it's much less data for English, but still, we also did really well for multilingual tasks. So we used the text characterization toolkit, which we published in 2022. And we wanted to look at the lexical diversity across the different data sets of English between GPT-3 and XGLM. So we found that there is more overlap between GPT-3 training and test data distributions versus less overlap between XGLM training and test data distributions. So taking a look at this peak here, this is GPT-3, and this here is XGLM. So the observation is that lexical diversity provides insights and interpretability to performance at scale, but also potentially pointing to having language-specific LLMs is better for complex tasks. So, think about now if we're trying to make the decision whether to build a language model that's specific to a specific language in order to address language, complex tasks, what would be the right choice? So what are the benefits of XGLM and multilingual LLMs? So as I mentioned, energy and maintenance efficiencies. From an engineering perspective, it pertains to a family of models that represent single unified models catering to many languages, which have wide application across many applications. Such a unified single model saves carbon footprint, and also a single model, despite having the risk of being a single point of failure, has the powerful incentive of being easier to maintain, access, distribute, and track. Models such as XGLM represent a paradigm shift from the Anglo-centric view of the world, of NLP, to being able to cater to all languages on an equal footing, but also paying attention to the design of these models is critical to ensure equitability and inclusion, exemplified by attempting to balance language representation. And possessing powerful multilingual models that can perform well, especially for medium and extremely low resource languages, helps alleviate the burden of creating supervised data for such languages, especially for the economically challenged languages, like medium to low digital presence typically goes hand in hand with economic disparities. But essentially, the way I think about it is not necessarily the all answer to this low research problem, low resource language research problem, but rather it could serve as a good bootstrapping mechanism for building even better monolingual models and so on, architectures. Moreover, having such models cater to scarcer languages spurs scientific research in such languages, leading to more diversified NLP and more diversified science in the broader sense. So, however, a single point of failure is also a disadvantage, as noted earlier, but it's also a potential for propagating dominant language biases, since complete equitable balance across languages is still a challenge. And the scale of performant models is still cost prohibitive for low resource languages and low resource scenarios. So what's the future outlook? Some recommendations for LRL research. Novel cross-lingual transfer and multilingual architectures of models is something that I think we need a lot more research to go into. So think about modular LLMs, adapters. I think investing in monolingual resources and models is critical. A hybridization of multilingual and monolingual models, I think, is the way to go. NLP enabled and empowered monolingual field linguistics, I think is very important. Resource and original LRL digital content generation, and trying to leverage sister sciences like sociolinguistics, psycholinguistics, and humanities studies like anthropology and ethics to help inform LRL research. And because we don't exist anymore in an isolated silo, we actually live in an ecosystem. And I think code switching is a very interesting area for research because it's a low resource scenario by definition, but it's also, it hits the boundaries of a lot of our architectures and a lot of our research designs. So I feel like code switching research, and we've shown it in a lot of our research that it's a very challenging area to whether to understand it or to actually generate it in a plausible manner. So some conclusions. Low resource language research enables building talent and technology locally while maintaining global communication, respecting variation and cultural linguistic nuance. No LRL research does not lead to fragmentation, since the principles of NLP, CL science are pervasive and shared. And yes, let's build the largest Ukrainian language model. And let's embrace LRL research as a first-class citizen in our research enterprise, conferences, funding, and outreach, because I believe that's the sustainability of the future of NLP. And I'd like to acknowledge Meta AI and colleagues and collaborators for this talk, but also I'd like to say Jaku, did I say it right? And Shukran, thank you so much.
Thank you, Mona. So I encourage everyone to use their emotions on Zoom to show how we love the talk. Thank you so much for this insightful talk and for sharing some of the current research going on at Meta, just for us, and for sharing your view on low resource languages, and the varieties of Arabic was something eye-opening for me personally. So we actually have 78 people listening to you right now.
Oh, wow.
So we have a really good show up. I'm very happy about this. I encourage everyone to use the Q&A tool or approach the microphone in the room in Dubrovnik if you have any questions for Mona. In the meantime, while you're typing all your questions, I'll start with the first one. And the first one goes as this: for XGLMs, if you add new languages, does it harm the quality of performance for other languages, or does it improve the quality for other languages? Like, what is the influence?
We don't know. We haven't tried it out, but I mean, I would assume that it maybe depends on the languages you add. So we were very particular in how we curated the languages because we wanted to make sure that we had representation from these 16 families. So basically think about it as clusters. If we add another family of languages or another set of languages that does not pertain to the 16, maybe a 17th one. Actually, how many families are there? I actually don't know now that I think about it, but because I thought it was between 13 and 16, but at any rate, we had 16. It was actually decided on by a lot of consultation with linguists. But the bottom line is we don't know if it gets worse or better. But we did notice that the best performant model was the one with the most parameters. As I mentioned, we had 4 language models of different sizes, and I only presented here the 7.5, but we actually the paper is like 100 pages, and in the appendix we list every possible variation in terms of scale.
I see. Thank you so much. The second question to you, Mona, can we download an XGLM model to test it somewhere, like Hugging Face or GitHub?
It is on GitHub, yes.
Okay, great. Good news. The next one. The scarcity of the data is a challenge, but at the same time, the scarcity of computational resource also imposes limitations. How low resource language practitioners can get an access to a GPU, TPU resources? We managed to train Electra, Roberta, GPT-2 for Ukrainian language, but it is hard to take the next step without enough computational resource. Do you have any advice?
Well, in the absence of national clouds and cloud credits from different places. So there are variants. For example, Llama now has a much smaller footprint. So I would encourage people to look into Llama as one option. And it's showing to be very competitive, by the way. So it's kind of surprising. So even those results that I did not put the charts that we got from, which compare, the numbers are pretty close to GPT 3.5 Turbo, which is the ChatGPT engine. So that was a very pleasant surprise. And people have already been experimenting with Llama left, right, and center. So, and in fact, people have been able to get the weights and so on to actually retrain. So it's you know, we're a little bit more open than other places. Now, I mean, reaching out to companies to ask them to give you, like especially Amazon, Microsoft, to give credits to actually be using to access their GPUs. So my own resident, who actually happened to be, unfortunately, he's my resident at Meta, but for some bizarre reason, visa reasons, he had to take a break, but he's still continuing the research. I don't know if I should say this publicly, but anyway, we've been purchasing GPU power from different places, and he's been able to retrain several language models out there, and it's relatively inexpensive. So we're looking at a choice of 0.6 cents, 60 cents for an hour of GPU use. So I mean, by American standards, it's not very expensive, I guess, but I don't know, with the exchange of currencies and stuff like that might be still. But I mean, there is hope. There is hope. So
thank you. And we have a question from the room in Dubrovnik. Please.
Hi. I was just wondering. So I mean, it was a really nice talk. But how do you at Meta handle questions of data ownership and community participation in the development of low resource friendly models and applications?
So that's a very good question. So let me tell you, legal is all over us. We are very, 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 very scrutinized because everything that we do is now becoming public. So because of the open science initiatives that we have internally. So first off, we don't engage with regular crowdsourcing. So all our annotators have to come through vendors that need to get psychological training. So for example, the hate speech stuff that I mentioned, these people were, they actually work for vendors that are contracting with us, and they get psychological support in addition to, you know, the whole thing is very, very well guarded from a legal perspective. And of course, we try to administer as much empathy and sympathy as, you know, because of the traumatizing nature of what they're doing. When it comes to, and this applies across the board, whether we're, you know, in the US or Rwanda or Uganda or Egypt or Morocco, across globally. And then this is one thing. The second thing is so for example, Llama, all the data that was in there was completely, we had copyrights access to it. Either we purchased it or we actually, it was publicly available, and every single license was cleared. This was not the case for OPT. OPT was less under the radar screen at the time we released OPT, but now everything at Meta is very well scrutinized. Even our papers now, they spend every single data set that you potentially even touched has to be legalized and sanctioned by, not legalized, sanctioned by legal. So does that address your question? Or
yeah, so I mean, the core issue, because I was talking a few weeks ago with a field linguist who goes out to very remote communities, and one of the concerns is, for example, like, where do they even store the data to make sure that it's not, you know, like eaten by Google for their modeling or whatever, right? Because these communities often want to have some degree of ownership of the data as it flows through the process. So there's a question of actually like dealing with these people during the actual development process.
Right. So I mean, in case of the Moroccan experience that I mentioned, as I mentioned, they're already contracted with us. I would imagine I don't think we do any field linguistics per se, but that's something that as I mentioned on my slide, I think is very necessary, especially for low resource languages. But this needs to be worked out, like the IP issues, who owns the data? Does it still belong to the you know, the people who are producing it or generating it? And how do they make sure that it's completely siloed or, you know, offset from other data, for example, if they don't want to have it mixed with or released or, you know, touched by other systems. So I believe that we have mechanisms as privacy is extremely paramount within Meta. And I've seen this also with AWS, Amazon. So I believe there might be some mechanisms. I'm not very familiar with exact policies there, but I believe that we probably have the mechanisms to handle that. Yeah.
Thank you.
Thank you so much for the question. And we have one more short one, just a confirmation whether on the slide we have shukran in Arabic as the near Daku in Ukrainian.
Yes, it is
correct?
Yeah, it's Arabic. It's read from right to left. And it's actually shukran jazilan, which means thank you so much. It's not just shukran, shukran jazilan. So it's
and we thank you, Mona, so much. A round of applause in Zoom and from me here. And we're moving to our next speaker. Okay, so next we have a session on data sets. And